Hi class, we are now on chapter 6.7, mass percent composition. I sort of already covered this in the previous one, but I'm going to give some more examples. So here is the formula I showed you, but now here is the actual formula using it again. But what if when I discussed chromium, we used it as a mass, and the mass was given to us. But what if we don't have the mass? What if we're asked to determine an element within a compound, and not just an element, but an element that there's more than one? So this is how we would set it up. So in this case, we have a compound that's made up of carbon, 2 chlorides, and 2 fluorides. Okay, so what we would need to do here is, let's take a look. We have an X, that's the element that we're interested in. In this case, it's going to be chloride. We're going to set this on top, and then we're going to take the whole mass of the sample on the bottom. So in this case, though, we have 2 of them. So we have the 2 on the top, but we have to multiply it by 2 to represent the fact that we don't have just one. We have 2 chlorides in this compound. So in this case, let's take a look. We have, this one is Cl2F2, but now we're going to actually do a problem. So mass percent composition, calculate the mass percent of chloride in Freon 114. So chloride here, we have 4 of them. So we need to do a few things here. We need to find the mass. We need the mass of this, the whole compound. We need the mass of the 4 chlorides, and then we can times it by 100. So in this case, hopefully this makes sense of setting it up with the chlorides. We have 4 of them. Make sure you multiply that. Those 4 have to be represented. And then we have the molar mass of the whole compound of Freon 114. So in this case, we have 4 times, I think it's 35, I don't have a periodic table in front of me, but it's 3547, I think, times that, and that equals 141.8 grams. The total compound, the molar mass of the compound is 203.8, times that by 100, and the 4 chlorides, the mass percent of chloride in this is made up of 69.58% of the compound. All right, so let's do another one. Acetic acid is the active ingredient in vinegar. Calculate the mass percent of oxygen in acetic acid. So again, we need 2 things here. We need the mass of the whole compound of acetic acid, the molar mass, and we need the mass of oxygen, since we need to pay attention, we have 2 of them. So in this case, we want the mass percent of oxygen. So we set this up, times it by 2, the molar mass of oxygen, and the molar mass of acetic acid times 100. So we have 2 oxygens, so 16 times 2 is 32. The acetic acid is the mass of 60.05, times it by 100. And the oxygen, the percent of oxygen in this compound is 53.29%.